It worked on Friday and at home this morning, but that was only with direct light and when the image was on the laptop display. It's working now with the display again. I made a few changes in the coloring, and it's getting better in low light. Let me print out a copy to see if we can make it work a few times without being on a digital display first. I don't like how much the light of the display seems to influence it. Could be something with the pixel configuration and not the image, and we want to isolate the image. If that works, then we can get everyone in the big room, Brendan answered, using the cautious, qualifying language that marked him as a former academic researcher. For him, even big breakthroughs came with qualifications. 30 minutes later, the small team was packed into a conference room. Brendan sat at the far end of the conference table, his laptop open, with its small camera pointed at him directly. He was wearing a dark blue T-shirt that had no other markings. His image was blown up on the big screen. The only difference was that on the screen, a thin, bright green rectangle surrounded his face. When he moved the chair from side to side, the bright green rectangle moved along with him. The laptop was running an open-source version of a commercial, off-the-shelf facial recognition program. At the time, it was not actively looking up who Brendan was, although it could be configured to run against databases of people and spit out likely predictions. In small sans-serif text at the bottom of the green rectangle was 98%, indicating the program's confidence that Brendan was a person. He started the demo by dimming the lights. He then moved his chair around the field of view of the camera. He stood up, he sat down, he turned the lights back on. All the while, the green rectangle followed his face with only the slightest lag time. Brendan centered himself in the camera's field and sat up straight. He then held up a piece of paper that had what appeared to be cover art for a band on it. It was printed on normal 8.5 by 11-inch printer paper in color from one of the shared office printers down the hall. It looked like it should have had text for a college town concert on it. As far as design was concerned, it was entirely unremarkable. Brendan moved the paper in front of his chest. The green rectangle around his face disappeared. The paper was not blocking his face. It was squarely in front of his chest, where the logo for a T-shirt might be. But with this unremarkable design, something truly remarkable had happened. He was now invisible to the computer. "Well, shit," said Tyler, a West Point-trained former U.S. Army officer and the leader of the team's growing national security practice. This could cause some serious problems for people. What Brendan and the rest of the team had engineered was nothing short of science fiction. Using a cutting-edge field known as adversarial machine learning, they had created a way to attack sophisticated AI machines with nothing more than a piece of paper. Adversarial machine learning can be thought of as manipulating an AI system to perform the way a third party, an adversary, wants instead of how it is supposed to function. For example, a cyber attacker can follow AI-enabled network endpoint protection systems into thinking that a piece of malware is actually goodware because of carefully inserted binary code and letting it onto a network. In other well-known examples, adversaries can force a self-driving car into mistaking a stop sign for a yield sign with carefully placed stickers on the sign that would be imperceptible to a human. Adversarial machine learning can be thought of simply as hacking AI. Unlike AI research, which has been around since the 1950s, research in the field of adversarial machine learning is only a decade and a half old, having been originally researched in 2004 when academic researchers wanted to understand how to fool spam filters. Research in the field remained shallow until around 2013 to 2014, when researchers began to understand how computer vision systems could be fooled by injecting noise into the images. By 2019, when Brendan fooled the computer into thinking he had disappeared, adversarial machine learning was a robust research topic, with thousands of academic papers being published each year.